The Fire Weather Index system produces daily FFMC, ISI, and BUI values that can represent peak of the burn period conditions based on weather conditions at the RAWS station near your fire. These daily ISI and BUI values can be used directly by the Fire Behavior Prediction System to estimate expected fire behavior. However, you may want to adjust the FFMC based on the fire location, time of day, and local weather conditions to more accurately reflect your fire situation. And though the buildup index, or BUI, does not change from hour to hour, you may have reason to adjust the value estimated from the daily situation assessment. Begin your local estimate of fuel moisture by reviewing your daily situation assessment at the top. Remember that you estimated a daily FFMC and BUI value for your area of interest, perhaps by averaging values from several adjacent RAWS stations. The 290 fuel moisture lesson pointed out that dead fine fuel moistures change throughout each day based on changing weather conditions. These are called diurnal fuel moisture trends that can be used to fine-tune the FFMC for local time and place. FFMC rises during the day and falls overnight. You'll notice the biggest declines come when it rains. It is important to use the assessment worksheet to track the process and your findings. Estimating local fuel moisture conditions requires several steps. The daily FFMC comes from the daily situation above. In most cases, during the peak burn period when fires are most active, the daily FFMC will be sufficient for your assessment. However, the FFMC can be adjusted for off-peak conditions when one of the diurnal adjustment tables can be used. Either way, the resulting FFMC can be used with local wind estimates to revise the ISI later in the process. This diurnal adjustment table for the afternoon and overnight hours is the one you'll use most of the time. In our example, assume that the daily FFMC was estimated to be 90. Remember that the daily FFMC is estimated at solar noon, but represents fuel moistures at the peak of the burn period, generally 4 hours later. Then pick a time that is of interest to you. In this example, we'll use 2100 in the evening. Where the 90 line and the 2100 column intersect gives you an adjusted FFMC of 88. That's the fine fuel moisture code at 2100 that evening. Record your results on the worksheet. During the morning hours, overnight humidity recovery drives the decline of fine fuel moisture code. In this case, use the diurnal FFMC adjustment table for the morning hours to make your adjustments. Assume that yesterday's FFMC was 90 and it is now 10 o'clock in the morning with a relative humidity of 55%. The intersection of the 1000 48 to 67% row and the 90 column produce an estimated current FFMC of 79 at 10 o'clock in the morning. Again, make sure you note your findings on the worksheet. It may be possible to use field measurements to estimate a 10-hour fuel moisture and convert it to an FFMC using this table from your guide. Remember, 10-hour fuels are between 1/4 inch and 1 inch in diameter. Another method for calibrating the FFMC is by backing in from fire behavior observations. If you know the fuel type and the buildup index, spread rate, and or fire rank or intensity class, you can estimate the ISI. Given the ISI and your local wind, you can work backwards in the ISI table to determine a local FFMC. As a last step, you want to confirm your daily assessment of the buildup index BUI. In most cases, you will simply carry the BUI from your daily assessment down. But if you think the local conditions are different, you can make an adjustment here. You want to use the BUI value to interpret how dry conditions are for your briefing and also in your fire behavior predictions. In this case, your fuel moisture assessment should be recorded on the worksheet and may look like this. Notice that the estimated FFMC includes a note that it is just the daily value for clarity. Finally, here are the points emphasized in this presentation on local fuel moisture assessment. The daily FFMC may be adequate for most burn period estimates of local fine fuel moisture code. Diurnal adjustments of FFMC can help identify the end of the burn period and off-peak values to use in your fire behavior assessments. Take the time now to review the other presentations about the FBP assessment process. Thank you.